We live in a hectic and stressful time. And I know the #1 question that was on everybody's mind when they walked through that door coming into pits today. How the heck do they get those cars to drive so fast at the Indianapolis Motor Speedway? Well, I'm going to try and answer that with 2 simple words, which happen to be the title of this speech: tunnels and wings. Those 2 technologies are really at the root of how they can drive so fast around those tight corners. Okay, there we go. So this handsome couple happens to be Dario Franchitti, the Scot who has won twice at the Indianapolis Motor Speedway, with his then wife, Ashley Judd, standing next to the Borg Warner Trophy. Next year will be the 100th running of the Indianapolis 500, and after each year, the winner's face is engraved on the trophy. All these are the faces of the 99 previous winners. So next year, the 100th face will be added to that. How do you win that trophy? Well, you basically are the first car to cross the finish line after racing for 500 miles. But getting back to my original point, how do they drive so fast, not in a straight line, but around a race course that has relatively tight corners? I'll take you back to the beginning of the golden age of innovation at the Indianapolis Motor Speedway. This is 1963, and Parnelli Jones was the winner that year at an average speed of a pole position, which was the fastest qualifier, average speed of 150 miles per hour. That was considered, well, it was a track record, that was considered a crazy fast speed to go around a track that is basically a rectangle with rounded corners. If you look at this diagram of the speedway, all of these colored areas here are grandstands for the public, but the black line is the track. It's not really an oval, it's a rectangle with rounded corners. In 1911, when they had the first Indianapolis 500, the track was configured to fit within an empty farm field that they purchased and bought the track on. With average speeds of cars going approximately 60 miles an hour during race day, there was no need for big, long, wide corners or heavy banking. As a matter of fact, the speedway has banking of 9 degrees, which is very, very shallow. It's almost considered a flat track. So from 1911 to today, the cars have increased in speed, but yet those tiny little turns are still the same size. To put it in perspective, this is the start of the race in 1996, and we're standing in the first turn, or the camera is standing in the first turn. So these cars are just about to enter that sharp left turn. If you look how long the straightaway is and how small that car is as it's exiting turn 4 to come down the straightaway, you get a sense of just how long those straights are and how tight those little corners would be. So from 1963, when Parnelli Jones was driving this car, which he nicknamed affectionately Old Calhoun, I presume because it was quite cantankerous, you'll notice that the tires are relatively thin and the driver is sitting upright, almost like we drive a car today. From 1963 to 1966, when Mario Andretti sat on the pole at a speed of 166 miles an hour, how did the speed jump 16 miles an hour for an average lap in just 3 years? This happens to be Jimmy Clark in his Lotus Ford, but you'll notice a few differences from Old Calhoun here. The driver now is in front of the engine, so the engine's been moved from the front to the back, and he's almost laying down. The car is much smaller, it's lower, it's lighter weight, it can go around the turns at a faster speed without degrading the tires or using more fuel. It actually had a smaller engine. This was the beginning of the rear engine revolution at Indianapolis. The next jump in speed is one of the technologies I'm talking about, and that's the addition of wings. Here's a huge rear wing on this 1972 Indy car and a front wing. Speeds now, by 1972 when Bobby Unser sat on the pole, have now jumped to 196 miles an hour. First because of rear engines, and then because of the addition of wings. How does a wing make a car go faster? Wings make planes fly, right? Well, the Bernoulli principle is used in Indy cars just like airplanes. And simply, it shows the shape of a wing as air approaches the wing, it's split, some air going above, some under the wing. The bottom of the wing is relatively flat or straight, but the top of the wing is curved. the air has to go faster to rejoin the air that went on the bottom of the wing at the same time. Therefore, the air simply just gets stretched out or thinner or less dense, creating a vacuum. So there's lower pressure at the top because that air is going further and getting stretched out, and ambient pressure at the bottom causing lift. The more air that passes over the wing, the more lift you get pushing the airplane into the air. IndyCar designers inverted that wing, causing the faster you go for it to push down on the car, increasing what's called downforce. So with the addition of wings, now we've jumped 30 miles an hour in just 6 years. The next breakthrough, tunnels, happened in the early 1980s, but it started with this ugly-looking little race car. I wish the picture was larger, but it's basically a square box, and it's a sports car, it's not an Indy car. But the technology started when engineers added 2 huge fans on the back of the car, powered by a snowmobile engine. They would start the snowmobile engine up, then start the race car engine. The snowmobile engine and those fans would suck all the air out of the bottom of the car, causing the air to suck down to the ground. This car was called a suction car, affectionately. It was soon outlawed by all the sanctioning bodies that you had these external fans, but it made the designers and the engineers say, how can we get the car to suck down to the ground? They did that by adding tunnels. Now this is a 1996 Indy car driven by Arie Luyendyk, who has set the average speed record at Indianapolis of 237 miles per hour in 1996. Arie's nickname is the Flying Dutchman, and you can see why at that speed. So you notice this car does have wider tires, front and rear, but it's very sleek. It is also low, where he's basically laying down with just his head propped up. Rear engine, the front rear wings, but underneath, where you can't see, one under each side pod, are tunnels. They have entrances about this size, but exits about this size. So as the air is passing through the tunnel, its dimension or its volume is being increased, which is basically sucking the air into a lower dense mass, creating a vacuum, or as they call it, ground effects downforce. So the car is being sucked to the ground by the tunnels underneath, pushed to the ground by the wings on the front and rear, allowing speeds that seem incredible by 1963 standards. The downforce combined with the ground effects in the wings triple the weight of the car. So an Indy car without a driver is about 1,500 pounds, pretty light car. At 230 miles an hour, 4,500 pounds total downforce is being created by the car. If you could create a racetrack made out of a long tube or a tunnel, at speed, the Indy car could actually roll up the side and drive upside down. If you could create a racetrack that way as well. So the future of the hover car with the Jetson family driving it around isn't that far off when you realize that the physics have been defied by the 2 simple technologies of tunnels and wings on an Indy car. And Toastmasters.